Now let's talk about what is GPU. So GPU technology is called graphic processing unit. So GPU basically helps you to execute the code. It's becoming more prevalent, especially with the imaging data. So GPU technology is again more of an innovation option that can help you to improve the speed of certain types of processes. And these are mainly used if you are doing any kind of parallel processing, which can require a computer system to think and learn. So while processing data as quickly as possible, it can be managed through the GPU technologies. Example where GPU technology is used in the chatbots, any kind of text generation or any kind of image recognition as well, right? So if you see in chat gpt, you basically have multiple gpus working to give you the best sort of results. Let's discuss gpu technology in detail. So gpu technology can help you to streamline the processes with a faster compute time, especially in the case of data science. So gpu is often discussed in relationship with machine learning. GPU is also used in gaming or in any kind of real-time human language task as well. So GPU can be faster at completing the specific tasks. I know it's better in and faster as compared to CPU, but the efficiency of GPU also depends on the type of computation which is being performed. So GPUs are great at tasks that can run in parallel. So if you plan to have any task running in parallel, GPU is the technology which can be used in that case. So implementing and maintaining the GPU can be a challenge because of fast evolving technology, because there's lots of innovation happening across in GPU area, and there's lots of energy which is consumed to keep the cooling for the GPU set of technology. So you have say input, you have CPU. So this is a typical CPU based work. So you have input, you have CPU, and then there's a sequential processing happening across in the case of CPU, and then you get a output. But in case of GPU, so you have input, you have GPU, then you can have multiple parallel programming or multiple parallel processing which can be done in the case of GPU. So now let's discuss what is algorithm. Algorithm again is a part of a computer program which can be viewed as an elaborate algorithm. So as a part of a computer program which performs a well-defined task, we call it as a algorithm. So algorithm is again a self-contained step-by-step set of operations which can be performed uh, by computer. Algorithm basically performs calculation, data processing, and it also help you to automate some kind of reasoning task as well. So some of the examples of algorithms are like, if you say a typical example, we say you go in the morning, you wake up and then do your brushing. So that's a typical algorithm which is infed in humans, right? So that's how everyday work is being done by people. So algorithm is a self-programmed kind of a self-executed kind of piece, which basically helps you to keep your day-to-day work, at the right pace. So these are few of the examples. So now let's talk about the classification of programming languages. So if you see programming languages, it can be classified in two areas, and this is an important slide. It can be asked from the exam questions perspective as well. So the programming languages can be of two types: low-level programming language and the high-level programming language. So in the low-level programming language, you have two more categories, which is say machine-enabled and the assembly language. So these are the two examples of low level programming language, so which is machine enabled and the assembly language. For the high level, you have again a classification into imperative or declarative. So if you see in imperative, you have the classification further as object oriented programming and the procedural programming, which we have seen already. So if you see C++, Java, or maybe even Python, these can also be referenced as a object oriented programming as well. And some of the procedural programmings are basically, if you see any of the microcontrollers, they used to have the procedural programming done as well. And now let's talk about the declarative uh, programming. So in declarative programming, what you have is you basically have your logic created, you have your querying done across, and then you have the functional modules which are built across. So you have imperative and declarative, and in imperative you have object oriented and procedural. In declarative you have logic, query in the function. So you can have a basic question being asked, in exam on the kind of the programming language. So you should always be very thorough with this kind of overall classification of programming language chart. Now let's talk about the classification of programming language again. As we said, there are three main families. So one is the machine languages, second is assembly languages, and this is third is a high level languages, right? So we have already seen this in the last slide. So if you see, you have a hardware which is like your computer hardware. So for interacting with a computer hardware, you need to have a machine language which can basically interact with your computer hardware. So on top of a machine language, you need to have an assembly language which can also run and help you to do the interpretation of the machine language. And finally, on top of it, you have the high level languages, and these can be say your Java, PHP, C Sharp, C++, or Python, and so on. So this is the overall typical hierarchy when your hardware interacts with the high level language. So you need to interact by machine language, assembly language, and the high level language. So the level of abstraction happens when you move from bottom to top. The abstraction level of programming from the hardware is what basically distinguishes the programming language. So with machine languages, it does not provide any abstraction because you directly interact with your hardware. Your assembly language basically provides relatively some level of abstraction from the hardware because you have machine language in between, and the highest level of abstraction is provided by the high level language. Now let's look at a very basic example of the machine language. So machine language, as we say, it's more of a computer programming languages consisting of binary or hexadecimal instructions which a computer can respond directly or execute through the likes of its CPU. So machine level language is basically a combination of zeros and ones. So it's form of a binary language which is a combination of zeros or one. So this is a native language of a computer, and it's very difficult to program in the machine language, right? Because if you misplace any of the zeros or one, the program will completely fail, and it's very tough to interpret the machine language by human mind. So as an example of machine language, so this is the kind of code which says you have 11101 0001 So if you see, the typical example is in this, the first and second, you just have one difference of one being moved out, but then the machine language will fail if there's a small change in a bit of the machine. So if you see in the similar capacity, in the third is again similar, but then there are changes as compared to the fourth. So every machine language is very hard to understand from the human perspective, and it's not a user friendly language from the human perspective. Now let's look at the examples of compiled languages versus the interpreted languages. So if you see the compiled versus the interpreted programs, so in the case of compiled languages, you have source code which get compiled and linked, and this can basically work on the platform specific binary executable. And finally, you execute it, your operating system will basically run the program. So this is the overall compiled program. So if you see the example of compiled program is basically you run your code in C++, you basically compile your program through Turbo C, and that's how you execute this across. The case of interpreted languages or programs, you have a source code, you basically compile it, and your interpreter basically run those programs. So there's another layer which helps you to interpret, and that's how the interpreted programs are relatively slower as compared to the compiled programs. And now let's look at the example of Python programs. In the case of Python program, you have a source code which get compiled, and your platform independent bytecode get generated, and this get executed via the Python virtual machine which is running the program. So Python is a classic example of a compiled program. And if you see interpreted program, so basic is one of the language which is more of a interpreted program.